Welcome to the 6.2 instructional video. 6.2 is sum and difference or double angle identities, and really what they are is a lot of formula sheet use. So make sure if you don't have a formula sheet, you can catch it in the Google Classroom under the the general materials. There's an actual formula sheet attachment in there. And I'm just going to pick one, just kind of maybe not at random. I'll pick the first one on the formula sheet, which is that the sine of angle A plus angle B can be written as the sine of angle A times the cos of angle B plus the cos of angle A times the sine of angle B. Now, there's lots of different ways to talk about this, but I think it's important that A and B can be any permissible value. Now, for sine and cosine, that's any angle. You can take the sine and cosine of any angle imaginable. When you run into the tan, you would have to be aware that you couldn't take the tan of A plus B if the tan of A plus B was one of those points on the curve that give us those vertical asymptotes, those non-permissible values. So in this case, though, I just want to really quickly talk about how whatever the angle for A is going to kind of transfer onto the right-hand side into these two positions, and whatever the angle B is going to transfer onto those two positions. Now, I'm going to just kind of make one up. What is really, really important is we should be able to do this for any angles, and one of the angles that I like to look at kind of right off the bat is the sine of 90 degrees. Now, hopefully, I know it's been Easter break, and there's always a time to forget things, but the sine of 90 degrees is just +1. Now, what's really important about this is the sine of 30 degrees plus 60 degrees is also the sine of 90, right? These are equivalent to each other. 30 plus 60 is 90. Now, what that means is if I take my double angle identity with this expression, I should be able to get +1 using my unit circle and basically just evaluating that. And I want to show you guys how that works. What I'm going to do is I'm going to try to color code this again. I'm going to keep my 30-degree expression in red. So we would have the sine of 30 degrees. I'm going to leave a little bit of space here. And then we'll also have the cos of 30 degrees. And then looking at angle B, I would have the cos of 60 degrees in that expression, and then the sine of 60 degrees would show up in the second term there. Now, in order for this to be true, we should be able to, evaluate the right-hand side and get +1, because the sine of 90 degrees is +1. So the sine of 30 plus 60 degrees should be +1 as well. And the way that we can do that is by using our unit circle. And so the sine of 30 degrees is 1/2. The cos of 60 degrees is also 1/2. Right? Just a coincidence that they're the same thing. That won't always happen. And then I'm going to add the cos of 30 degrees, which is √3/2, and the sine of 60 degrees, which is again √3/2. Kind of a weird example because we're getting similar numbers in each term here. Now, what I can do then is evaluate this. 1/2 times 1/2 is 1/4, plus √3 times √3, which is 3, divided by 2 times 2, which is 4. And I hope we all agree that 1/4 plus 3/4 is 1. Now, maybe I should have skipped here. I'll put it over here. That 1/4 plus 3/4 is 4/4, which is, if we go with my regular classroom analogy, if I eat a quarter of pizza and then a 3/4 of pizza, now I've eaten a full pizza. So one whole number there. Most of 6.2 is just kind of following these sum and difference identities. Where this can get a little bit tricky is it's really important, and we talked about this kind of even before this COVID break, that we know the sine, cos, and tan of 30, 45, 60 degrees, and any angle that has those as a reference angle. And what's really important about that then is if I ask you to find maybe the sine of 75 degrees, if you look on your unit circle for 75 degrees, you're going to be looking forever because it's not on there. So what we have to do in an odd situation like this is recognize that we can write 75 degrees as the addition or subtraction in some cases of 2 of these angles because we know those angles. So instead of trying to find the sine of 75 degrees, I would find the sine of 30 degrees plus 45 degrees, then use my sum and difference identities and identify it from there. Now, I do want to show that because at this point we've come too far. It doesn't make sense to not write it. Ooh, it's going to come in 2 parts there. This is going to be equal to, and I'm following my identity, the sine of 30 degrees times the cos of 45 degrees plus the cos of 30 degrees times the sine of 45 degrees. And now I could evaluate these piece by piece. The sine of 30 is 1/2. The cos of 45 is √2/2, plus the cos of 30 degrees, which is √3/2, times the sine of 45 degrees, which is √2/2. When I multiply these out, this first term is √2/4. My second term is root 6 over 4. You cannot add radicals unless they have the exact same radicand. So this would be my form. Now, what's really important about this is if you have your calculator, I encourage you to check this, put in the sine of 75 degrees, and your calculator is never going to tell you root 2 plus root 6 over 4. What we have to recognize is that this value right here is the exact value of that expression. So the sine, sorry about the green there, the sine of 75 degrees is exactly that. If we wanted to find the approximate value, which I don't want to lie to you guys, it has value. Approximations, I mean, if I'm building the shed in a backyard, I don't really need that to the nearest 6th decimal place, or root 2 plus root 6 over 4. So if you do have your calculator, take a quick look, and if I plug in the sine of 75 degrees, my calculator tells me that that's 0.965925823. And if I plug this expression in carefully, and I just want to write that out, that it would be root 2, you're going to close that bracket, plus root 6. Now I would hit enter at this point, or throw that in a bracket, and then divide by 4. And you will get the exact same decimal. We talk a lot about exact form versus approximate form. Make sure you read those questions carefully, because if this is approximate form, jump to your calculator right away. But we are going to ask these questions for exact form to ensure that you can use those sum and difference identities.